Let's see if this broadcast is working correctly. Looks like it is, right? Is it working? Yeah? Oh, there's nobody in the room? I'm just talking to myself? Okay, got it. Thanks. Hello, everybody. It's good to see you. It's a pretty crazy time to be talking and hosting this thing. By the way, let me know if you can hear me okay. It's crazy times. We have people with the quarantine and the corona stuff. We have riots going on in the US, crazy stuff. Black Lives Matter. There's a lot of injustices going on over there. And it's kind of weird to sit here and talk about mock objects when all of this stuff is going on. So I'm in Israel. So that's very far away from where a lot of that stuff happens, but I'm also in quarantine. So I think the very least we can do is try to be a little bit of escapist for now and try to talk about some stuff that is to do with technology and about the book. And if you're part of a lot of the stuff going on in the US, and then I hope you're safe and I hope that you're okay. And if you're quarantined at home and you're stuck, I hope you and yours are safe and you're okay too. So yeah, that's my intro, I guess. A lot of fun stuff, as you can see. It's kind of weird. Anyway, while we're talking about COVID as well, I want to make sure that everyone knows about this website right over here. So I've made all of my unit testing training stuff free during COVID quarantines. Basically means if you go to this website, there's a course there called COVID All In. You register for it. It's free. You can choose to pay $5 if you want. Doesn't matter. Matters to me, but it doesn't matter because a lot of people have lost their jobs due to the quarantine stuff. A lot of people are aching financially. So when we're back from quarantine, a lot of people are going to be looking for new jobs. And I want to make sure that I'm contributing my part for whoever wants to learn this stuff to have a leg up when they're searching for a new job. So you can, if you want to learn unit testing and TDD and refactoring and all that stuff, you can go to this website and you should be able to get all of the training for free. And even after quarantine is over, if you registered, the training will remain free for you. So that's for you. I think that's for now. Let's see. What did we want to talk about? Oh yeah, mock objects, right? By the way, I'm watching the chat as well. So if you want to ask questions during the chat, feel free. I want this to be a inclusive experience, which is fun and interesting. And that's really a lot of it is up to you, how interactive we can make this. Okay, so why don't we actually start? Okay. Okay, you should be able to see my my slides here. Don't worry, we can also jump into code examples as well, based on feedback. Okay, so the next hour is going to be dedicated to mock objects. Well, really mock objects and stubs and all the differences between them. I find that there's a lot of sources for miscommunication about that stuff. A lot of stuff going on where people call something mock and something stub and they don't even know the differences between them. So I'm here to explain the way I view these things. So again, if you have any questions, feel free to ask in the chat. Okay. So, oh, by the way, I'm going to do all of the examples in JavaScript because, I wrote a book called The Art of Unit Testing, and I'm currently writing the 3rd edition of it. So the first 2 editions were written in C#. The 3rd edition is going to be rewritten in JavaScript. We already have the first 4 chapters ready. They're actually part of the MEEP, which is the Manning Early Access Program. So chapter 4 is really about mock objects. I'm going to cover a lot of the material from chapter 4 and also chapter 3. So if you're interested, a lot of this is going to be based on that book. Oh, by the way, I'm also on Twitch, and I'm trying to see if I can get as many Twitch subscribers as I can to, I don't know, just to have this kind of a live audience. So please head over to Twitch and register. Like and subscribe and smash the like button and do whatever it is kids do. TikTok me or Snapchat this and whatever. I don't know. Head on over and do the clicking thing, and we'll figure it out from there. Okay, that's kind of what I'm asking you to do. A little bit about my background. Yeah, you MySpace me. Okay, someone gets my humor. I like that. Let's drink to that in these really, really sad and weird times, right? By the way, it's 11 p.m. here, so it's almost midnight here in Israel, which is nice and interesting. Hold on. Okay. Perfecto. Okay. So if we want to understand the idea, oh yeah, I was talking about myself. I should not forget. So I come, I have 20 years of experience in software. I worked as a team lead and architect and a bunch of other stuff in a lot of companies. But I have 3 main passions: test-driven development and unit testing, team leadership, and continuous delivery. Enterprise continuous delivery, really. So that's where the third book I'm also working on is in progress as well. So if you want to learn more, it's on my website, all these links. Okay, let's go back to basic. Let's talk about units. What is a unit? Because once we understand what is a unit, we can start talking about what is a stub and what is a mock object as in regards to what a unit is. So a unit, when we say unit in unit testing, what do we usually mean? The way I think about units, and this has changed over the years. I used to think that unit is a function, but then I didn't really like the fact that a unit can also be like a private function, because I don't usually test private functions. And then I was in the opinion that a unit could be a class, but it can also be smaller than a class. And sometimes it can even span multiple classes. So these days, what I think a unit is a unit of work. And a unit of work is basically a flow of information through the application that has entry points, and exit points. So it is defined but it starts in an entry point and it ends in an exit point, one or more exit points. Here's what I mean. A unit of work represents whatever happens from the entry point, which is basically a function that we invoke somewhere, because we are programming, right? So once we invoke a function, we should be able to trigger, and this function, by the way, is public. It's something that is publicly visible. It's not a private function. Once we trigger that function, we trigger it because something needs to happen. So we're expecting a behavior, and that behavior is something that is publicly noticeable. So what types of behaviors do functions have, right? If we're thinking about what a function can do, what do functions actually do? Why do we call functions? Well, the first example of calling a function, we all know this, is we want to get back a value, right? So if I call a function, I can get back a return value or an error. So I'm calling the API and I'm getting back something. So at the same level of the API, I'm also getting back something. That's the simplest part. That's awesome. Those are also some of the easiest stuff to test. Sometimes we call functions and those functions don't actually return values, right? Some functions are void. They don't actually return anything. So what do these functions do? Well, some of these functions have noticeable state change. What do I mean by a noticeable state change? Well, let's say that I'm calling a function called add user, but it's void. What does add user do? Well, obviously it does something, or I wouldn't be calling it. It adds a user to the system, which basically changes the state of the system. So what do I mean by noticeable state change? It means that I can view the behavior of the system change in some way from the same level where I invoked the entry point. Okay? So if I invoke some function, either I invoke some function again, or I invoke another function and I get back values based on the new state of the system. For example, I might try to log in with a user that I just added because the state changed, then the login will succeed. And before that, it didn't succeed. So the second example of a function is that it returns doesn't return a value, but it changes state. And of course, a function can do both. It could return a value and change state. Okay. Let me just make sure I can see everything here. What else? Then we have the third type. We have a function that might not return a value and might not change state. What does that function do? Well, some functions call third parties. For example, a function that sends an email. So far, so good. So it sends an email. It doesn't change the state of my own system. It changes the state of another system. If I'm writing to a log file, it changes the state of the file system, right? If I'm saving stuff to a database, it's changing the state of the external database. So all of these things can be called third parties or dependencies. So a unit of work is everything that happens from the invocation of one entry point until we reach one of the exit points. That's all it means. Now it could mean that this function can call multiple functions inside the unit of work, or even multiple classes or components or modules until the exit point is reached. I don't test private stuff, so I only care about stuff that is publicly visible. And that's the definition of a unit of work. Why is this important? Because stubs and mock objects only play the most important roles in some types of exit points. So what do I mean? Let's see. So if my test is calling a return value, it's calling a function called sum, and it gets met numbers, and the function doesn't have any external behaviors, doesn't have any side effects, it's a pure function for all intents and purposes, then we don't need mock objects, we don't need stubs, we don't need anything. What about a function that returns a value but also changes state? In that case, we could start thinking about maybe using a mock object, but usually we don't want to use a mock object here yet, because the publicly visible state change, even though it's not considered pure functional behavior, and I'm not going to talk about too much about functional versus non-functional for the next hour. But if we're trying to invoke something here, we can also test the total so far, like another function now returns a different value. So let's say we call sum, and every time we call sum, total so far keeps adding more and more stuff. So the state is keep changing. So again, we don't need probably mock objects or stubs for that type of stuff, because there's noticeable system behavior. Same public API, I can act and assert at the same level. So if I'm invoking sum, I can assert on the result of total so far. Okay. But what if we have now something like this? What if I'm saying, okay, whenever you call sum, I want you to return a value, and I want you to change the state of the system so that the totals are updated, but I also want you to log the result. So now the logger can represent for us a third-party dependency. It's a third-party dependency because it's code we didn't write. It's maintained by a team that we don't own. It could be broken and then affect our code, and we won't be able to fix it. So it represents a dependency, something that we can't control from our code and from our tests usually. And that means that instead of that if I wanted to test that it calls a third party, it would be difficult for me. It would either force me to do an integration test, which sometimes is a good idea, but not always. And I would say that most of the time, integration tests, and I mean the integration tests in the sense that they're complicated and have a lot of dependencies, integration tests usually create a lot of trouble. So we want to minimize the amount that we have. We still want some, but we don't want a lot of them. So what if I wanted to prove that something calls a logger? That's where mock objects can start coming in. So from a unit of work, we have a public API that gets invoked by the test, and then it either returns a value, changes a state, or calls a third party. Right? So if I'm returning a value, should be very, very simple. You invoke something, you get something back. No cats were harmed in this experiment. What about state change? Again, this is not my GIF. This is not my child, but it's a good example of a publicly visible state change. So you change a setting on the light, and you observe the face of the child, and you can see that the face has changed. The state of the face has changed, okay? And last but not least, an example of a mock object. So if you've ever been to ATMs and you've seen what thieves can do, they'll put fake keyboards on top of the ATM, and those fake keyboards will then record the numbers that you put in. And then at night, the thieves would come back in, will take the plates, will connect them to their computer, and view all of the access codes with the credit card numbers attached. So in this case, because the thieves don't control the ATM and they can't hack the ATM, they actually said, okay, what if we input a layer of indirection between ourselves and the ATM? And that layer of indirection is under our control. And this is a perfect example of what a mock object is. It is something that looks like something else, but it allows us to query it. And when we query it later, we can decide whether something works or doesn't work. Someone is writing on the chat, non-urgent terminology clarification. If a function has multiple pathways to exit points, i.e. via conditional branching, do you consider each pathway to be a distinct unit of work? Oh, great question. So if a function, let's say that sum does 3 things. So it returns a value, and it also changes the state, and it also calls a third party. Each one of them is a separate test. Each one of them is a separate test that invokes the same function, but has a different assert, because each one of them is a different requirement from the same unit of work. So technically, that's 3 units of work, or the same unit of work has multiple exit points, but each exit point represents an expectation, a requirement in my application. Hopefully that makes sense, and that answers the question. Okay. So it's very easy to just invoke a public API, right? Unit of work, it gets invoked. We get back a return. We assert on the return. Life is nice. Everything is easy. Just beautiful. And those are the simplest types of tests. And if we can just get away with these types of tests, I would highly, highly recommend it. And then noticeable state change. We invoke the public API, and then we basically assert on something that's noticeable. Now, we can't see the assert here, but technically the assert happens, you see here at the assert. I'm invoking the public API in part of the test, and the assert is somewhere on the public API. So the assert might be on the same function or in a different function at the same level. And third parties, that's again where we are stuck. A third party, we invoke a public API. Let's say we want to call a logger or save to a database. We are invoking the unit of work. It calls a third party, calls the unit, the other third party, the unit of work in a different location that we don't care about. And now what? How do we actually assert against it? We can't, right? Let me put it this way. If I had an application that sends an email, how would I test that it actually sends an email? It would suck. The test would suck because there were so many things that had to be true for that test to pass that are not under my control. The test would take a long time, would be complicated to write, would be complicated to maintain. It would break constantly. And so those tests are not usually very viable. I would name that test, if I were ever to write a test like this, a system test. And system tests are notorious. Just ask anyone working at a company, a decent-sized company, that are trying to raise a production environment for testing, and they don't have infrastructure as code and continuous delivery pipelines. Just ask them, and you'll see just how complicated it is to set up an environment with all of these dependencies. It's just crazy. So a lot of times we want to abstract away that third party so that we can control it. Okay, so that's where mock objects come in. So a mock object comes in so that before I actually invoke the public API, I replace the third-party dependency of my unit of work with my mock object. It looks the same. If I were working in C#, it would be having the same interface, etc. If I'm working in TypeScript, it's the same way. If I'm working in JavaScript, it's just a function in memory, so it's very, very easy. But basically, I'm replacing the real thing with a fake thing. And then, and this is very, very important because we want to understand the difference between mocks and stubs, and then I assert on it. So if I assert on that fake thing, then I would call that a mock object. But if I don't assert on that fake thing, let's say that in a different test, I don't care about the logger, I don't care about the database, I'm just stubbing them out. I'm just getting rid of them so that I can test something else. So I don't care about them. In that case, we would call them stubs. So the main difference, the way I see the difference between mock objects and stubs, is that let's see. Okay, so the main difference I see between mock objects and stubs is a mock object and stubs are both types of a fake object. They're both types of a test double. But if I assert against it, then it becomes a mock object. So the same object in one test can be used as a mock object, and then in a different test, the same test can be used as a stub. And the difference is that a stub makes happy noises, or we don't actually assert on it. We use it to get rid of stuff we don't care about in the test. And in other types, when we actually care about what is the output, what is the external result, was it saved to a database? Was the external API call actually invoked? In those cases, we would actually use that as a mock object. Hopefully that makes sense. And if you have more questions about this, please ask me in the chat so I can answer them, because I want to make sure everyone gets this. Let's see. Okay. So that was kind of the theory of it. Hopefully that makes sense. Questions before maybe we'll jump into a little bit of code. It's not very complicated, hopefully, right? The whole idea is that we have dependencies we don't control, and then we fake them. Now, by the way, this is where a lot of the way people call things really is really important. If I'm saying that I'm going to mock the database, and I'm going to mock the logger, and I'm going to mock this, I'm going to mock that, when I say I'm going to mock something, basically in my head that translates to I'm going to create a fake version of that, and I'm going to assert that it was called. But most people, when they say that they're going to mock something out, they actually mean that they're going to stub that thing. I'm going to stub the database and return a fake value. I'm going to stub this, and I'm going to return something else. Actually, let me see if I can show you a different graphic that shows this even more clearly. Hold on. And meanwhile, if you have questions in the chat, ask them away. Okay. Yeah. So I'm just gonna make this like this. I think that's good enough. Okay, so here's the difference between a mock and a stub in a visual way. Sometimes a unit of work will have an exit point to a dependency where it invokes a dependency, and that is the end result. This is what is expected. For example, calling a logger. So that's called an outgoing dependency. That's where we would use a mock object, because I would replace that thing with a fake thing, and I would assert that it was called. So I would invoke the entry point here, and then I would assert that this arrow happened. But sometimes we have incoming dependencies. So for example, in my unit of work, I'm invoking something, and I'm expecting, let's say, a return value, but I also have a dependency on an external thing. So I'm trying to get something from a database, from a configuration file, anything, from the network. So those things are providing information or behavior into the unit of work, and I'm testing the end result based on that. So this is not an end result. Notice the direction of the arrow. Another difference between mocks and stubs is the flow of information. Stubs provide behavior or information into the unit of work. Mock objects receive information or invocations from the unit of work. Okay? Question. Mock and stub is a distinction between command and query. You can definitely think about it like that. I haven't thought about it that way, but yes, you could definitely think about it that way. I think at some point it kind of made a connection a while ago, and then I never discussed it. So yes, I think command and query, if we're talking about design sense here, and let's say pure functions, for example, a lot of things start to connect when we talk about mocks and stubs. But we also have to remember that because design, especially in our existing applications, can vary a lot. We can be working on an application that has a lot of tightly coupled things, a lot of dependencies that are both incoming and outgoing, etc. So when we talk about mocks and stubs, we want to be very explicit, because what we don't want is to assert on stubs, because that creates tests that are very, very hard to maintain, creates a coupling on things that we shouldn't care about. I'll explain that in a second. You mentioned the cascading problem of if you're trying to test third-party code in addition to your own, your tests get huge and unmanageable. That could, for third-party code, i.e. other services in your own code, that's nonetheless outside the scope of your current unit of work. This could also apply to non-third. Okay. Good question. So the question is, well, what if I have a third-party service, but it's actually maintained by my team or by a different team sitting right next to me? Is that a third party? And the question is, it's your choice. It's really your choice. And what I like about this discussion, and this usually what happens is, once we start defining a unit of work and its dependencies, we can start deciding what is a dependency that is a third party and what is a dependency that we can control. So if you can technically control that third-party code, or if you want to bring that code and use it at runtime, you could. Technically, you don't have to stub something out just because it doesn't belong to you. Sometimes, actually a lot of times, we'll use objects that we don't control in memory because they're simple, let's say, data objects, etc. So I only fake things that are either creating issues for me in my tests. For example, they make my tests slower, or they're really, really difficult to simulate complicated situations. So for example, an email, if I wanted to test a variation that says, when I'm trying to send an email and the server returns to me reached full quota on the email, then I want you to show this message to the user. If I wanted to simulate this with a real email server, that even if it's maintained by my team, that test could still take a long time and be very complicated. So I would still probably use it as a stub to simulate something that otherwise would be very, very difficult to simulate. Question. Our system has over 300 components, and sometimes it's much simpler to just mock stuff than use the real stuff. Well, I'm thinking ET 901 is that you're really talking about stub stuff, okay? And yes, you can definitely when we're talking about, again, the distinction between mock objects and stubs, one of the reasons we want to name them differently is because, and this is really, really important, everybody, okay? If there's one rule about mocks and stubs that you should remember, is that in my test, I should have no more than one mock object. Well, I could, but I probably shouldn't, because a mock object represents an exit point. It represents a requirement. Remember this? It represents a requirement, and I'm testing only one thing per test. But a test can have multiple stubs, because the same unit of work can have multiple dependencies, like a database configuration, network, 3 other services, but I'm still testing only one single exit point in a test, in a unit test usually, which basically means that I can have one mock object, but I can have multiple stubs. And if I'm testing another exit point, just a return value, I shouldn't have a mock object at all. If I have a mock object and an assert on a return value, it basically means that I'm testing 2 things at the same time, and I would usually want to separate them into two different tests. So dependencies for mock objects represents requirements, which is basically the idea of testing one single thing. So let's say that I have 300 components, and it's really hard to recreate all of them, and I'm just testing this small piece of code. Technically, yeah, sure, you can fake out a lot of these components, but there is also a small risk in that. Actually, not so small. You definitely want to have some tests that are more at the component or integration level, that use multiple components and even use the network and databases, because you want to have some confidence that at least for a couple of tests, all of those things together actually work together. If you only test each one of them in an isolated manner, sure, technically each one of them works separately, but you don't actually have confidence that they work together. So usually what I would recommend to people is that when they work on these types of tests, they have multiple levels of tests. Actually, I think I might have a variation on this. Let's see if I deleted this or not. Hold on. Let's see. I think I have an example of this. Where is it? Hold on, everybody. I want to show you, this is related to our discussion. So I'm going to share another screen for a second. Okay. There's something in my teeth. Okay. Okay, so if you have 300 components, then you're probably facing something like this, right? Just make that bigger. That's what she said. You have a bunch of tests that you want to test, that you might choose to run. So then the same scenario can be tested either as a unit or a component or integration or API test or an end-to-end or a system test. At which level do you want to test something? And what ET901 is saying is, well, yeah, sure. Well, it's very easy to test here. And then I'm just going to fake out. I'm going to have a bunch of stubs for the other components. And then that's basically it. That's awesome. But you still want at least a few tests at the upper levels. In fact, I would argue that for any system that is sufficiently complicated, to gain enough confidence, you want to have at least a few, usually 1 to 5, 1 to 10 of end-to-end tests. But then the variations of those end-to-end tests will be tested at lower levels. So this is what it might look like. I have this one feature. You see the feature is ending here. This is the red line. So for that feature, I have a bunch of scenarios that I would like to test. This scenario right here, I can test it as an end-to-end. But then maybe that's just a login. What about all the variations of how logins can fail? Well, I can test some of the variations as an integration test or maybe as API tests. And once I've tested a couple of variations here, I can test internal variations on those variations, right? At lower levels as unit tests. What's very common for a lot of companies is they're saying, well, we prefer end-to-end tests. First of all, it's easier for us to write it. So then they go and they write all of the scenarios only on this level right here. And then they would end up with a lot of end-to-end tests and almost no unit tests. And what does that mean for us? Well, it means that our build pipeline is going to take 5 or 6 hours, sometimes days. It means that we can't get feedback fast enough. And it means that a lot of tests are going to be breaking for no reason, because there's a lot of noise at that level of things that breaking when they shouldn't be breaking. Here, what we would get is we get very fast feedback on these, and then these two would give us confidence that at least I have kind of this connection between the top layer and the bottom layer, and everything technically works together. I have another question here. How do you manage to make tests with mocks that don't break often when implementing another feature? It's a great question. Usually, when I talk about the design of the unit of work, I will make sure that my tests will only test public functions, and I'll make sure that I'll only test at the exit points of the unit of work. So I don't test internal stuff, and I don't assert on stubs. It's it's a really common anti-pattern. So what does it mean asserting on a stub? Let's say that you have a unit of work that calls a database here and receives information from the database. So I might fake the database and say, well, let's say that the database returns 2 people to you, and then in that case, I want you to show success as a result of something. So technically, the database is used as a stub for that test. But a lot of people will go ahead and also verify that the database was queried correctly. So if you assert on queries, if you assert on reading something, let's say assert that someone reads the configuration, then technically you're asserting on internal interactions. And that creates glue between your test and internal implementation that is really, really difficult to untangle later. And the example that I'll usually tell in class, because I do a lot of training, by the way, I've started doing training online, kind of like this, but with Zoom and breakout rooms. So if anyone's interested, hit me up later, right? We all need extra work at these weird times. So when I usually teach, what I usually tell people is that when we were living in Norway, I had, I have three kids, and we were living in Norway. They were 1, 3, and 5. And when I was, so let's say I send my my oldest, my 8-year-old, when I was living in Norway, send him to get me a pizza. And it's the winter, and it's snowing, and it's cold. So I'll send him down the street to get me a pizza. So I'll put some money in his hands. And then I'll say, you go to the pizza place, and then you go and you say good morning, and then you'll put this down, and you ask for this pizza, and then at the end you'll say thank you, goodbye, and then you'll take the pizza back to me. And then maybe an hour later, my kid returns shivering, all cold. It's just a story. Don't take it seriously. My kid returns shivering and cold. Daddy, here's your pizza. And I say, that's awesome. Okay, but hold on. Before you come in the door, let me just make a quick call. And then I'll call the pizza place, and I'll say, hey, did a kid come by? Okay. Did he say good morning? Okay. Did he say thank you? Oh, he didn't say thank you. Okay, well, thank you very much. And then I would hang up the phone, I'll take the pizza, and I'll throw it on the floor, and I'll tell my kid, you have failed. And that's basically how I think about testing our stubs. Yes, and when we're saying the London School of TDD, yes, definitely. I'm not saying I'm not a fan, but I usually work in a more of in a more defined manner, where I try to minimize the amounts of interactions that I assert. So when I'm asserting on stubs, that's basically what I'm doing. I'm testing interactions that are not important for my confidence. That's the way I think about it. Now, if you've heard about the London School of TDD, etc., it took me a few years to really understand what that was about. At the beginning, I was really, really against it. But then I realized that actually we have a lot more in common than we think. Because when we think about the exit points here, that I show in my presentation. The London School of TDD also talks about those things. It just doesn't call it exit points. So when it says interactions, it also means those interactions sometimes at the outer system level. So at the end of the day, I don't think that we're that far apart. But I used to feel like that approach was about testing internal interactions, but that approach doesn't actually have to be. You can use that approach outside in TDD, etc., and you can use it and still come up with a design that kind of looks like this. But I don't think that a lot of people really understand it the way the authors actually meant it, and I think that causes a lot of unnecessary friction and riots. I think that's that. Where was I? Okay, so we're talking about mock objects, types of exits, blah 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 blah. Here we talked about this. That's okay. That's cool. We have the outgoing dependencies. I think that's fine. Do we have any other questions? Should we jump into some code maybe? Yeah. Okay, let's do a bit of a coding. Let me turn on the code. Share screen. Okay. By the way, question: if you sometimes use mocks as stubs, how would you name the mock class itself? Oh, good question. If I am going to create a class that is going to be used as either a mock or as a stub, I will name it fake something. So I'll call it fake logger. And the word fake to me basically signifies that the same thing can either be used as a mock or as a stub. Hopefully that answers the question. So I'll just use the word fake whenever I'm using something that could be used as either at some point. Okay, so let's see. Can everyone see the coding, the codage? Okay, so the example I'm going to show for now is just a very simple verify password function. And it's in JavaScript, and hopefully that's okay with everybody. It shouldn't really matter because the patterns are the same patterns, right? We can basically say right now it doesn't use the input, but I can say let's say if input length is bigger than 0, return false. I'm just gonna add something here. So just as a simple, just as a quick exercise, just to explain what I'm doing here. Let me know if you can read the fonts, by the way, if that everything's good. I have a function here called verify password. It takes a bunch of rules and an input, which is a string. And right now, it doesn't really do much. And what I want to do, right, I have a couple of tests for it right here. So I have a test that says, well, given failing rule, it always fails. Given a passing rule, it always passes. Well, what if I wanted to, what if I had a logger somewhere? Right? What if I have a module for a logger somewhere? So let me actually create a module here. Let's do, I'll still create it here. Let's just do it here. Let's do it, call file. We'll call it my logger.js. The reason I'm using my loggers is to simplify things. Oh, what should the logger be? It's just a simple, it could be a function, doesn't really matter. We can say const info. That's just a function. Actually, let's call it log, const log. Function that takes text. So far, so good. And oh, you know what? I have a shortcut for this. Const on, yeah. Log is a function that takes text. And for now, we'll just say console log text. Amazing, 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 right? Actually, you know what? Text plus, because it has added value. Okay, maybe you can do that. Template string, okay. And then we can say module exports is an object that has the log function. That's it. So now, let's say that in my verify pass, you know what? Let's do. Let's see if I can move that. Let's do a new file. We'll call it verifier.js. And I'll go back here and I'll take this function right here. I'll cut it and I'll paste it here. And I'll do a module exports is just a model that has verify pass. That's it. And so let's see if I can just import it here for my tests. Perfect. Far so good. So I've just kind of refactored it so that we can see the dependencies. Let me actually just run the test. I'm using Wallaby and WebStorm, so I'm just going to run the test here with Wallaby. It's a commercial product, but I still like it. They gave me a free license, and I'm a happy user, but I'm not affiliated with them in any way. Let's see. Okay, so I can see the tester passing, and this is the verifier, and this is the logger. So far, so good. So let's say that we want to add this dependency. The dependency is I want to make sure, let's say that if the length is 0, I want to prove, and I'm not doing TDD for now. I'm just showing the dependency. Log empty input here. Okay, I wanna do something like this. Log empty input. Okay, so we can talk about multiple ways of designing this, but you know the standard way of how people usually do it in terms of design is the most unfortunate way. Okay, the most unfortunate way is because it's also usually creates the most annoyance for us when we're trying to override these things. They'll do something like const log equals require, and then we'll say my logger, right? And then they'll do, well, log, let's see, of course, like this. Cannot find module my logger. Oh, logger my logger. There, yeah, okay. And you notice, by the way, how quick I got the feedback from Wallaby. Let me just undo that so you can see. You can see it cannot find module right here. I didn't actually have to save or anything. And I can see the results here as well. So as soon as I just add the missing characters, everything turns green again, and I can see everything, which is pretty cool. Okay, so now we have a dependency on the logger, and we would have, how would we prove that log actually gets called? That's, for us, that's an example of what could be a dependency in our tests. So before I show about this kind of stuff, let me show how I would refactor the code to make it more easily testable. One way is to, instead of getting the log as a require, is to get it. And I'm talking now about the most functional, more functional design, but we'll also talk about the object-oriented design in a second. If I was in a functional world, I could say, well, just add log as a function into the as a function parameter into the verify pass function. And what would that allow me is basically to create to every time when I call verify pass is to call it with 3 parameters, which we all agree would be quite annoying. But in the functional world, we can use currying, and we have a bunch of frameworks for that kind of stuff that would allow us to configure verify pass as a function that takes the first 2 parameters and gets configured and gives us another function that only takes an input. So technically, we can treat it almost like a class with a constructor. I do believe I have an example of that here. Let's see if I can show that. Actually, let's see. We can just do that manually. Hold on, everybody. I'm trying to share that stuff. Why is it not working? Corona. Why is it not working? What the heckity heck? Okay. Hold on. I think I found the issue here. Sorry about that. Sorry. Okay. So let's say I have the log here. You know what? I'm just going to write it here for now. So if I go to my tests now, notice that by adding this functionality, I now have a problem. My problem is that all of my existing tests are failing. So the first thing I need to do is to add a stub for all of my existing tests. So we're going to ignore the refactoring that we're going to do later, but how do I provide a stub into verify pass? And the answer is I can just provide a stub function like this. Const log is a function that takes an input and does absolutely nothing, right? That's it. So I can say, you can actually, I'm going to name it fake log. And I can share it as the first parameter, fake log, like this. Okay, I'm giving you the most basic example, but already you can see that I'm using a very basic handwritten stub here. I'm just going to put it right here. So fake log doesn't actually do anything. And I can do the same thing here. Fake log. So now my existing tests are passing, and I'm not actually asserting that fake log was called because that's not what I'm supposed to do in these tests. If I want to prove that it gets called, I can do it in a separate test. But right now, fake log is just used as a stub. Okay, so far so good. What if I were to try to prove that the logger was actually called, the logger function? I can write a new test here. We can say given logger and empty input calls logger. Notice that I'm providing 3 pieces of information in my tests. The thing being tested, the unit of work, the scenario under test, and the expected behavior. Okay, so now what would I do? Let's do another fake log, but this time we'll call it mock log. const mocklog is a function that takes an input, right? And in fact, what I'm going to do is I'm going to say const was called equals false. Okay. And all I'm going to do is I'm going to say was called is true in this function. Can you do that? Oh, yeah, I made it const. So I'm creating a very, very basic, and for those of you who worked with mock objects, you might think I'm doing a lot of extra work. Do you know DOSA? DOSA? I don't know what DOSA is, or that person, but I'm sure you're going to explain in a second. Let was called, and so I'm just doing something very manually because I want you to understand how usually mock objects work. Okay, we're going to make it simpler in a second. DAO set v he's hosting you. No, are you hosting me? Am I being hosted right now? Oh, this is freaky. Host me, dude. Host me all night long. Okay, so we have this kind of a mock function, right? It's not a mock object, it's a mock function. But in JavaScript, functions are objects, so technically it's a mock object. What am I missing? Oh, we actually want to do something, right? So actually, I'm just going to say const result. I actually don't need the result. I'm just going to do verify pass with the mock log function. And it doesn't matter which rules, and an empty input. Okay. What do I assert against? Can anyone guess? Guess. Guess for me, guess for me, guess for me. Oh. Come on, it's almost midnight. Can someone guess what I'm going to assert against? Okay. Disappointment. What's called? Okay, thank you. There's a lag, right? There's a lag. That's why I was disappointed. Too fast. Expect was called to be true. And of course, the thing I always hate happens. The test is passing. I have no idea if it's a good test. So I'm actually going to go here. I'm going to go to my function to verify pass. You can see it's green here. And I'm going to comment out this line. And now I should have a failing test, which I do. I click on this. Pass verification given logger and empty input calls logger, expected true, but was false. So I've proven that the call to a third party was called by creating a mock function. So far, so good. I guess that makes a lot of sense. But if I were truly using, I could verify the text as well. Of course, I could definitely just do written equals text input. But remember that my input is supposed to be empty. Oh, no, it's not supposed to be input. And in that case, I could say, let's written equals, let's do an empty string. And I can say written to be empty input. Right? If I was empty input like this, it would fail. Expected empty input, received empty input. This also provides kind of the same thing. I don't need what's called, that doesn't exist. But this allows me to, here I'm basically testing that the string was correct, which is also great. Since I'm using jest, there's an easier way to use jest here. I can say, check it out. I can say const mock log equals just.fn. And instead of saying written, I'm going to say mock log calls length to be. So no, not length. Was it mock log dot calls? Log. Let me just find the syntax for a second. Just fan search. Forgetting. I have that here. Where is it? Oh yeah, of course. Sorry about that. Expect mock log to have been called with t input. Sweet Jesus. What if I do this? Fails. Okay, so what does the just fn give me that I didn't get before? Well, just fn basically saves the arguments and allows me to assert on them later, which is nice. It's kind of like a nice little shortcut. Questions while I clean my teeth? Okay. Questions, answers. Questions will be answered and answers will be questioned. I'm probably not going to go far too long today because it is midnight, okay, people? It's midnight. Come on. Okay, so that was a very basic idea. What if, okay, and now that was kind of more of a function-based. What if I was expecting an object, which is a very common thing to do? If I was expecting an object, so the design would look like this. So this is a not log, this is a logger, and I would say logger.log. If this is, what if this was the expected design? What could I send in as a mock log, as a mock logger actually? Const mock logger is just an object. And that object has a function, which is called log, right? And here's the kicker. I can just do that log is a just fn. No worries. So now I can say, send in the mock logger and expect mock logger dot log to have been called. Same difference, same. If I wanted to do the mock logger without just fn, I can say, I can do something like this. Const mock, actually const fake logger is an object that has a log method, which is just a function, right? It takes an input. Well, I can just do that like this, right? Log is takes an input and does something to it. What would it do? It would actually save the value. So I can, I probably do it like here. So I can do it in the test. This const written. Notice that the only difference is that it's an object, more object-oriented way, but it doesn't really matter. Const written equals an empty string. And then in the log, I'll say written is the input, which is almost basically what we did before, right? Oh, it has to be let. Again, same issue as before. And then how would I expect? I would just say expect written to be empty input. Oh yeah, now I'm want to say fake logger. Hopefully that makes kind of sense. Now, as we're creating these fake objects, what if we had a class? What if our object wasn't a function, it was a class? So it would be something like class, verifier. In my class, I can technically create a constructor that takes a logger and saves that logger here, right? Nothing fancy. And then I would have like a verify pass function. So I would have like a const verify, um, const verify pass takes, I don't know, is a function that takes whatever the rules and the input. And what? Const verify pass. Oh yeah, of course we can't do verify pass. We have to do a function, sorry. Function verify pass. This. What am I missing here? Yeah. Maximum amount of objects you would tolerate in constructor injection. If it's, well, you have to remember in JavaScript it's a bit easier because we can do destructure. So almost always I can refactor things to one object. So as soon as I have more than 2 or 3, I'll start refactoring into a parameter object. That's basically the number that I'll go for. Let's do an input here like this. Function verify pass. What am I missing here? Oh, use, of course. And then in the pass, I can say, if input length is 0, then this logger log, empty input. It's the same, same crap, different day. This function will use the thing in the constructor. And it's very common in languages like C# or Java is to use constructor injection so that we can make the dependencies explicit. So again, in my case, I can, in some test, I'll inject a stub in the constructor. And in some test, I'll inject a mock object in the constructor. And the difference is what my test is doing with that fake object. Okay? That's why I call it fake. And I think that kind of answers a lot of the questions. So I want to make sure, are there any other more pressing, interesting questions that we can answer? I think we're going to finish in the next 10 minutes. Questions about mocks, stubs, and everything in between. Let's show that, this is an example. Oh, by the way, there are some isolation frameworks, or people call them mocking frameworks, but again, a lot of them are being used for creating stubs as well. So I call them isolation frameworks, and they exist for almost practically any language. But specifically in JavaScript, I haven't found a lot of frameworks that I really, really like. Xenon.js would be one of them. Testable would be another. And a lot of them take a lot of the stuff that I just did manually and they make it a bit easier. So that's basically it. But as long as we understand the difference between mocks and stubs, we should be more than okay. And of course, if you want to learn more about these differences, there's a bunch of stuff on my blog, osherove.com/blog. And there's part of unittesting.com. I think those are two very useful sites. What is it telling me? Come on. It's not a typo. That's my name, dude. Observe. Come on. Yeah, I'm going to save it. Okay, any other questions? Answers? if from inside verify pass, you call the logger twice or call it with garbage and then the expected value, it will pass. You don't go that far to test for those cases, right? So that's an example of where usually those isolation frameworks will help you, because they'll verify that at least one of the calls that happened. Technically, yes, I would have to do more work if I know that there are going to be multiple calls, which is making a good case for using frameworks like Xenon, etc., because they save a lot of that very annoying thing. But if even just by using JustFN, I'm able to verify that even the third call still injected the right thing. And here we have to worry about another thing that we haven't discussed yet, and that is the difference between strict and non-strict mock objects. So a strict mock object is a mock object that basically barfs or throws an error as soon as you call it with something that it didn't expect. So as soon as you call it with garbage and you didn't make it expect garbage, it's going to throw an error and fail the test. A non-strict or a relaxed mock object, which is what I usually recommend, will say, dude, don't worry, you can call me with whatever you want. And then later, just ask me. And if one of the calls actually match what you were looking for, it's going to be okay. That's usually what I would recommend, because it makes our tests much more maintainable and future-proof, especially with stuff like loggers. Today, I'm calling it with this input. Tomorrow, I'm going to add 50 more inputs. I don't want to go ahead and change my test 50 times every time I add another input to the logger on something that I don't even care about for this specific test. So using relaxed mock objects instead of strict mock objects makes a big difference. Not asserting on stubs makes a huge difference. Understanding the differences, separating tests so that each test only tests one thing makes a huge, huge difference. Other questions? Answers. Okay. We're just about to finish. Does anyone want to ask me any other last-minute question? Do I have any coffee left? Yeah, I do. No flies in the coffee. Okay. All right, everybody. I think that's it. Oh, yeah. Okay. You're watching my course on GoTDD. That's cool. Yeah. Oh, by the way, I forgot. Remember, I still have this stuff here, right? Just go here. Everyone who's interested in learning unit testing and TDD, all of my courses are free for the COVID stuff. So usually they cost a lot of money. So now they don't. Sharing the love, as they say. So feel free to use them, enjoy them, and that's it. May the force be with you. Yeah. Okay. Thanks, everybody. I want to say thank you to Manning for supporting me on the third edition of this book. Manning has been with me from the beginning. That making the insert in the same shape of the Go stones was brilliant. Oh, that's part of the YouTube videos. Okay, that's cool. Thank you to Manning. You guys are awesome. And thank you for all the listeners. Oh, please register for my stream. Come on, don't be assholes. Come on, everybody. Just go to the Twitch thing. It's right over there. I think it's written. It's written. Oh, it's the other way. It's that one. That one. Yeah, I appreciate it. I do appreciate the kind words. Okay. This was fun. And if anyone wants to ask me any more questions or just contact me, you can contact me on the Twitters and the TikToks and the whatever, and find me on the MySpaces. Okay. Cheers, everybody. Be safe in the corona. Be safe wherever you are. I love you. Cheers. Peace. Don't mock everything. Okay. Bye.